Hello everyone, we are going to talk about the process monitor basic item for Dry-Etcher. The process monitor function is to make sure this equipment is ready to product in a basic good condition. So we use the monitor to watch the Dry-Etcher running capability. If it is in the spec, we can use it to run product. If it is off the range, control range, we have to stop it production. First of all, we're going to monitor the particle condition of the Dry-Etcher. We measure the particle number. If the result over the limit high, we cannot allow it run because the particle pollution is too dangerous to product semiconductor wafer. So if the particle measure result too high over our limit, it means it get dirty, too dirty to product. The way we send a clean dummy wafer into the machine and run by a specific recipe just for the particle test recipe. The procedure: Step A. Dummy run by the particle recipe with the clean wafer, just as the figure. Step B. Measure the result, the particle number, before run and after run, to get the particle increasing values. Before run, we measure the particle number. After run, we measure the particle number. Then we can get the particle increasing value. If increasing value over our set limit, we stop the machine to inspect and PM. If it is in our set limit, this machine can continuously running. Not just the dry etch machine do this way. Almost all equipment use this way to test the particle condition. The secondary step, we measure the etching rate and the etching rate uniformity. If the etching rate value and the etching rate uniformity value at the limit range, high and low this time, the equipment can run to product wafer. The procedure is like this. Step A, we use the dummy wafer and we grow a film, or we can say we deposition a film on it. This film, we want to etch it. For example, if we are going to check the etching rate of oxide film, we grow the oxide layer, or we call it oxide film, ready to be etched to test. Okay. You want measure the material A to test its etching rate. You grow a material A film on the surface of the dummy wafer. Then send to run to etch the film with specific etching recipe. Of course, this situation will use the specific etching recipe. For example, we want to etch the oxide layer, the oxide film. We use the oxide etching recipe to etch the oxide film. And step B, after etch, the film will be less thickness. Then we measure the film thickness and to compare the thickness before and after value. The film before thickness value we already know. This step, and after etch we measure the thickness as after value. Obviously, we use the thickness before value. Minus thickness after value divided by fixed time. We can get the etcher rate. It means in a fixed time how much thickness can be etched by the recipe, and we get the etch rate, or we can say we get the etch capability of this equipment. It's very important. We want to etch everything in a thickness spec during a fixed time. No more, no less. Just in the limited range we want. Step C. Now we are going to measure the uniformity of the etcher rate. For example, this is the dummy wafer. After etch, we measure the thickness 0.1, 0.2, 0.3, 0.4, 0.5 and less. We measure the 5 point as step B to get 5 point etcher rate. According to step A and step B, we measure 5 points, the center and the edge 5 points of the wafer surface fin, and to get 5 points its etcher rate. Then we get 5 etcher rate values. We also get the maximum value and the minimum values of etcher rate from the 5 points. Then we use the formula uniformity percentage equal max value minus minimum value, then divided by max value plus minimum value, then plus %. This is the times after times 100%. We get the basic uniformity percentage value. We call it uniformity percentage formula, and we get this value. It must under the set limit the uniformity percentage, less is better. Okay, that's all. See you next time.